Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 80. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to rewrite my equation here. 8 to the power of x is equal to 80. And now, my first step to solving this problem is rewriting 80 as 8 times 10. So now I get 8 to the power of x is equal to 8 times 10. And now I can go ahead and divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to, all that's left here is 10. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over 8, well, 8 is the same thing as a to the power of 1. And a to the power of x over a to the power of 1, by using this property, is going to equal a to the power of x minus 1. And this is equal to 10. Now from here, I'm going to take the log on both sides. So I get log of 8 to the power of x minus 1 is equal to log of 10. And the reason I take the log on both sides is because now I can use the property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So log a to the power of x minus 1, I can move x minus 1 to the front, and I get x minus 1 times log 8 is equal to log 10. And this property is really important because before, x was an exponent, and it's really hard to solve an exponential equation, but now we moved x, and now it's a real term, and it's much simpler to solve. So now what I'm going to do is distribute my log x here. So now I get x times log x, or log 8, which is equal to x times log 8, minus 1 times log 8, which is just log 8, is equal to log 10. And now I'm going to add log 8 on both sides. So then these two cancel out, and I get x times log 8 is equal to log 10 plus log 8. And now we want to isolate x. So what I'm going to do is get rid of this log 8 by dividing both sides by log 8. So then these two cancel out, and I'll be left with x is equal to log 10 plus log 8 over log 8. Now log 10, that's equal to 1, if you guys already know. So I get x is equal to 1 plus log 8 over log 8. Now, this is the same thing as 1 over log 8 plus log 8 over log 8. And log 8, these two cancel out, so I'm left with x is equal to 1 over log 8 plus 1. And log 8 is equal to 0.9031. So I get x is equal to 1 over 0.9031 plus 1. And 1 over 0.9031 is equal to 1.1073, and this plus 1 is equal to 2.1073. So this is my answer. Alright, so in this video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 8 minus 121 is equal to 0. Now, what most people would think to do to solve this equation is add 121 on both sides. So then I would get x to the power of 8 equals 121. And then, since x is to the power of 8, take the 8th root on both sides to get an answer of the 8th root of 121. And this method is actually wrong because there are actually many more solutions than just 2 to this equation. There's many more. So we want to find all of these solutions to this equation. So how are we going to do that? Well, our first step is to rewrite x to the power of 8 as x to the power of 4 times 2. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 times 2 is equal to x to the power of 4 to the power of 2. Now I have this minus 121, which we can rewrite as 11 to the power of 2. And the reason we're going to do that is so now we can use an important algebraic property that states that if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x to the power of 4 and b is 11. So I get x to the power of 4 plus 11 times x to the power of 4 minus 11, which is equal to 0. Now, from here, I get two equations. I get x to the power of 4 plus 11 is equal to 0, and x to the power of 4 minus 11 is equal to 0. And we are still not done yet, because to solve this equation, people are going to think, oh, add 11 on both sides and take the 4th root. But we're going to do the same thing we did with our original equation. I'm going to rewrite x to the power of 4 as x to the power of 2 times 2. And now I can rewrite that as x to the power of 2 to the power of 2. And 11, I'm going to rewrite as the square root of 11 squared. So now I can use this property again. So I get x squared plus the square root of 11 times x squared minus the square root of 11 is equal to 0. And again, I get two equations. I get x squared plus the square root of 11 is equal to 0, and x squared minus the square root of 11 is equal to 0. Now, what I can do is, for x squared minus the square root of 11 equals 0, I'm going to add the square root of 11 on both sides. So then these two cancel out, and I get x squared is equal to square root of 11. And now if I take the square root on both sides, square root of x squared is x, and the square root of 11 is the 4th root of 11. This is positive or negative. Now for x squared plus the square root of 11 is equal to 0, I'm going to subtract the square root of 11 on both sides. So I get x squared is equal to negative square root of 11. So now I get the square root of x squared is equal to the square root of negative square root of 11. So the square root of x squared is x, and the square root of the negative square root of 11, I can write this as negative square root of 11. So now this is the same. So now if I take the square root on both sides, I get the square root of x squared is equal to negative square root of 11, or sorry, the square root of negative square root of 11, which I can rewrite as x is equal to the square root of negative 11 to the power of 1/2, which is equal to negative 11 to the power of 1/2 to the power of 1/2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 1/2 times 1/2 is 1/4. So I get x is equal to negative 11 to the power of 1/4. Now going back here, I have x to the power 4 plus 11 equals 0. So I can subtract 11 on both sides, and I get x to the power 4 equals negative 11. Now I can take the fourth root on both sides. So I get x is equal to the fourth root of negative 11. And this is positive or negative.